see on the slide the components of the hydraulic system. Now what you can see here is, this is the block diagram of the hydraulic system. Now if you can look here, this is the oil tank, right? So oil is stored in this tank. It is also called as oil reservoir, where the oil is stored. Here you can see there is a pipe through which the oil from the tank moves upward, and there is a filter placed here. Now obviously there can be some particles which are suspended in the oil, or some material, or sometimes the reusing of oil will change the properties of the oils and make some particles in the oil which have been suspended to settle down at the bottom of the tank. And after a certain period of time, if the oil in the tank gets disturbed, these settled particles will move up and get mixed with the oil, and they will start entering into the system. So there may be certain impurities, some suspended particles would be there. So we need to remove these unwanted particles from the oil, because these particles, these impurities in the oil will create friction in the moving part of the system. These particles in the oil, suspended in the oil, will create friction with the moving part of the system, and that will affect the motion, or the smooth motion will not be possible. So we need to filter these particles through using this system in the filter. Then obviously to fetch the oil from the tank, we need this pump, right? So that enough pressure can be created within the oil, which is required for the movement or the motion, as well as it can be lifted from the lower level to the upper level. So you can see here the tank is at the comparatively lower level, while the filter, pressure regulator, this is called as direction control valve, load actuator, these are at little higher level. So we need to fetch or move this oil from lower level to upper level, and for that we need this pump and motor arrangement. So when this motor starts, the pump will start fetching the oil from the tank. It will get filtered here, and the pure oil will start moving to the pressure regulator. Now this is also a kind of valve or a switch. Now as the name suggests, what is a regulator, pressure regulator?
We can vary the pressure using it.
Yes. All of you must be having gas cylinders at your home, and it comes with a regulator, isn't it? Regulator comes with a pressure gauge. Pressure gauge, the device which can measure the pressure in the system. So a regulator comes with a pressure gauge. So on the scale of this pressure gauge, we can read how much pressure is coming out of this regulator. You can set this pressure here, 100 bar pressure, 200 bar pressure, and that pressure will come out of this regulator and will be applied to this direction control valve. Now this valve is again a switch, and you can see that it's a 3-position switch. Now, what are these positions? 1 is the off position, 2 is the forward position, means the regulated, that is the oil in the coming out of the regulator will be passed through this direction control valve and passed, or will be allowed to come out of the system or this valve, and will be entering here. You can see this cylindrical structure. This cylindrical structure is called as actuator. So what is happening in this cylindrical structure is, if you can see this ulta T, inverted T, can you see? This is called as piston. This inverted T is nothing but piston, and at the upper end of this inverted T, a load is attached, a load is placed. So when the switch, the direction control valve, is at position 2, it indicates that the forward path is open, or the forward path is enabled, we can say, and the oil passes through this valve and enters into the cylinder. Now imagine, now you can see that this inverted T, which is nothing but a piston, this is called as piston, is at the center of the cylinder. Listen, this piston, this horizontal part of this piston is at the center of the cylinder, and now the oil starts coming inside the cylinder from the upper side. What will happen with the piston? Whether it will move from its position? Will it move from its position? Yes or no? Are you getting? If you have any doubt, you can ask.
Yes.
See,
No,
I
ma'am.
repeat, no, I repeat, suppose the piston, see here at the bottom side of this horizontal bar of the piston, there is nothing. Now you can see there is some oil, this dotted portion is nothing but the oil. Now you can see there is some oil because we have started the operation of the system. Imagine that there is no oil on the lower side. What is the position? The piston is at the center of this cylinder. This is a cylindrical structure, so we call it as a cylinder. And inside the cylinder, there is a piston. So this piston is at the center. And now when we start this, or when we have the valve position at number 2, that means the forward direction is enabled. That is, the oil will start moving in forward direction and will enter into the cylinder. Now the question is, will this oil will push the piston in downward direction? Yes or no?
Yes.
Yes, ma'am.
Yes,
Yes, ma'am.
definitely,
Yes.
definitely we need to set the pressure. We need to set the pressure to such a value that the pressure is enough to push the piston in downward direction, isn't it? The pressure should be enough. The pressure should be high enough to overcome the weight of this piston. Then and then only the oil that is coming inside the cylinder will be able to push the piston in downward direction. So accordingly, we need to set the pressure through the pressure regulator. Now considering that enough pressure is applied, which is required to push the piston in downward direction, then what happens is this piston will move in downward direction and the load attached with the upper end of this piston will also in downward direction, right? And obviously there is certain space at both the ends of this piston. In the diagram it is shown to be touching to the edges or the walls of the cylinder, but actually it is not touching, it is having certain space or gap. So when the oil enters and pushes the piston in the downward direction, it also goes to the lower part of the piston, right, from the space around this horizontal part of the piston. And then that excess oil, that oil which has escaped from both the sides of the piston, is returned back through the direction valve. Now here position 3 is for return. So we need to turn the valve on position 3 so that the return path is enabled. The return path is connected from the cylinder back to the oil tank, and now the oil in the bottom side of the actuator, which is nothing but cylinder, will move back through this direction control valve. You can see the arrows. It is in the return direction. Now here it was in forward direction, here it is in return or inverse direction, and it goes back to the oil tank, and hence this system is called as closed system. And getting this, why the hydraulic system is called as closed system? We cannot allow this oil, right? We cannot allow this oil to go out from here. We cannot keep this pipe open, isn't it? Otherwise, the oil will spill out, and that will lead to the slippery floors, as well as that will cause the fire hazard. So we cannot allow it to do so. We have to take care. We have to put the pipelines in the reverse or return direction, which will go back to the oil tank. Hence, it is called as closed loop system. Right? And now suppose we have stopped the oil. Now, when we start the return path, the forward path is obviously disabled. Right? When we start the return path, forward path is always disabled. And when forward path is on, when forward path is enabled, the return path is disabled. So now can you understand the meaning of direction control valve? Switch the control valve on position 3. So forward path is closed and return path is enabled, and the oil inside the cylinder will come out and go back to the tank. And now when there is no pressure on the lower side, and there is a spring below this piston, अभी क्या हुआ, ये सारा ऑयल बाहर निकल गया. अभी ऑयल जब बाहर निकल जाएगा तो we can see there is a spring inside this cylinder at the bottom side of this piston. Now when all the oil moves out into the oil tank due to the spring action, what will happen with this piston? Piston in downward direction. When you stop this oil and allow it to return back, when oil goes back to the tank, the spring action will move the piston in upward direction. Again, you start the flow to allow, put the position of valve on 2, forward path will be enabled, oil will come inside the cylinder, piston will move in downward direction. Now put the switch on position 3, forward will be blocked, return path will make the oil to go back to the tank, and the spring will move the piston in upward direction. And if you continuously toggle between position 2 and position 3, what will happen with the movement of this piston? It will continuously move upward, downward, upward, downward.
Upward and downward.
Right? But these are the basic components of a hydraulic system. It consists of oil tank, a filter, pump, a pressure regulator valve, a direction control valve, and an actuator. These are the basic components of a hydraulic system. Clear?